Application of delta-epsilon definition of limit. So we have a problem that an engineer need to cut out a square that is of area 144, and the engineer can only have plus or minus 8 centimeter squares errors that they can make. So how precise can the engineer cut the piece of material in order to be within the error tolerance? In order to solve this question, we need to understand what situation are allowed. So if the engineer cut a square that is exactly 144 centimeter square, so it will have a 12 by 12 square. So each side, if it's precisely 12 cm, then you get a 144 centimeter square. And in that case, you will have an exact answer. But in real life, sometimes we might cut the square a little bit smaller, but sometimes we might cut the square a little bit bigger. But what is allowed is that you cannot have more than 8 square centimeter of errors. So in that sense, the square cannot be smaller than 138, and it cannot be bigger than 152. So, and then you can also calculate, okay, if it's less than 152, what is the side length? And if it's exactly 138 square centimeter, what is exactly the side length? So we can use a function to understand what's going on and be able to calculate our error precisely. So this function is, we know the area of a square with side length x is just x squared. So we're gonna plot the side length x and the area A, and it should be a parabola. So assume that this is a point of interest, okay? Right here is exactly 12 cm, and we have a 144 cm square, okay? So what it's telling us right now is that as long as we are within 8, so plus or minus 8 of 144, it will be fine, okay? So this is what's allowed. So the max you can have is 152, and the minimum you need to have is 138. So what is a restriction on the side length? So when we go down from here, so what side length will give you an area of 138? You just do square root of 138. You get 11.6619 and so on. Okay, so that is how long the side length is. But if you are cutting a slightly bigger square, you get a side length of 12.3288 and so on. So this is the error tolerance. But we cannot just say, okay, it can, we need to give an error tolerance. That means we need to say it has to be plus or minus a number, right? And we call that number delta. So as long as we're within delta from x, my limit will be plus or minus epsilon from L in this case. So then we use the delta epsilon definition to understand this. But just by looking at the graph, you'll be able to see, okay, so how long, so if this is delta, my delta will be 0.3288. And if that is my delta is, what is the difference between 12 and 11.6619? It will be 0.3381. Okay? So then the question is, how do I choose my delta? You should choose the smallest. Okay, why? Because if you choose a larger one, if you choose 0.3381 away from 12, it's telling you that you can go up to 12.3381, which is right here. And if you go up, it's more than 8 away from 144. So we should choose a minimum of those numbers to be our delta. Minimum of 3381 and 0.3288, right? And our delta would just be 0.328. Now, so we will choose this number, and then the question is, we need to round it. We need to round our answer. So to be precise, right? I would accept the answer 0.329. Okay, but if you want to be precise, it's really 0.328. Why? You can just do it. Okay, you can do 12.329 square. So you go to your calculator, you do 12.329 square. You realize it's a little bit more than 152. So in that sense, you really need to suppose to put down this number if you need to round. Okay, but if you put the 4 digit, it should be fine. Okay, it's still within, as long as it's within 152, less than 152, then it is acceptable. But this is just looking at the graph. How do we use the delta epsilon definition to solve this rigorously? I'm going to show you in the next video.